Let's continue to the problem 4 here. This question is about sinusoids and the phasors. The first sub-problem in this, problem A, is that what value of f will cause the v0 in the above figures to be 0. From here we know that omega is equal to 2 pi and f, which means that we have to find this omega, right? So how do we find the omega? We have to know something related to omega here, and that we know that the impedance have the omega in it. So we're gonna calculate the impedance for the capacitor first. We know that it is 1 over j omega c, right? And then I will sub c here to be this value, and then we know that it will be in this form, and then ohm here, and then the impedance for the L, we have an L here is equal to 10 over minus 3 Henry. Yeah, gonna sub this so that we can get this value. And where should we go next? Let's see the condition for this problem. We note in the above figure to be 0, right? Let's go back to this basic equation. We know that V0 is equal to I multiplied by the total impedance. The total impedance of this circuit is the impedance of capacitor plus the impedance of the inductor, right? So in this, which one will be 0? And I will tell you that it will be this value. So we can write that the impedance of C plus the impedance of L is equal to 0, which means that the impedance of C is equal to the minus of impedance of the inductor here. Yeah, let's sub this value in this equation. This j will cancel each other, and then we will have the omega squared is equal to 10 to the 9 here. So we can get this value to be of omega, and from the calculator we know that it will be radian per second, or we can write this in kilo radians per second. Yeah, which means that we will know the value of the frequency from this, right? Is 2 pi f is equal to omega, and we know that 2 pi of f is equal to this value. F will be from the calculator. We will know that it will be hertz. Yeah. So we know that this frequency will cause the V0 to be 0, and then we finish the problem A here. Let's continue with the B problem here. We want to find the voltage drop across these element here, here, and here. As you can see that it is connected in series circuit like this. A very popular formula to calculate a voltage drop across in a series circuit is the voltage divider. Let me recall you that in this circuit we have the voltage source V here, and then we have C1, C2, and C3. Yes, the C total for this circuit is C1 plus C2 plus C3. In case that we want to know the voltage drop across this C1 here, the formula for it is the voltage is equal to C1 over by CT multiplied by V. Let's apply it to this problem too, and we have the V out here, right? V out here, and then the CL is equal to this value, and then the C total here is this plus 1. This will cancel each other, and then we multiply this by the voltage source, which is 1 phasor 0 here. By this we can get that the voltage for this inductor is this value, volt. We will use this value for all of this too. And another one is the voltage for the capacitor here, which will be this value. And then the voltage for the R which is 1 here. In the problem C here, we have to draw the phasor diagram for these voltages. And we know that from the previous calculation, the voltage for the L has a phasor of 90 degrees, right? Then we know that this and this one have a magnitude of 31.62, and we can know again that the V for the capacitor is have the same magnitude but with a different phasor. And we know here that the VR is having a phasor of zeros and the magnitude of 1 volt. And that's all for this question.